Good morning, dear students. Today we are going to learn the chemistry paper number 6th, part 1st, that is organic section. In this, the first topic is name reactions and mechanisms. Name reactions and mechanism. In this topic, we are going to see the different name reactions and their mechanisms. The different name reactions are oxidation reactions, reduction reactions, and condensation reactions. Firstly, we will see the condensation reactions. In condensation reactions, the first reaction is benzene condensation. When benzaldehyde undergo condensation with potassium cyanide, then it gives to you benzoin. This is the example of benzene condensation reaction, and this has a general reaction. In general reaction, aromatic aldehydes or glycols undergo condensation with a mild base to give acetylene. And in particular, we have taken the example of formation of benzoin. This is simple reaction because there are three components. One is benzaldehyde, another is potassium cyanide with base, and third is benzene, that is product. Then we are going to see the mechanism of the reaction. In mechanism, the potassium cyanide undergo dissociation to form K plus and Cn minus ion. This Cn minus ion now will attack on the carbonyl carbon of the benzaldehyde, and there is formation of an oxyanion. The oxyanion now abstracts a proton from the adjacent carbon, and there is formation of a carbanion. There is formation of a carbanion. Now this carbanion is very unstable, so that it tries to attack on the another electrophilic group. This electrophilic site or group is provided by the second molecule of benzaldehyde, and the carbanion attacks on the carbonyl carbon of the benzaldehyde. Now there is formation of another oxyanion. Then in the next step, a proton transfer from hydroxy-oxygen to oxyanion occurs, that is, there is intramolecular proton transfer, and a new oxyanion is formed. Now this oxyanion is very unstable, so that it donates the electron to the adjacent carbon, and there is loss of cyanide minus ion, and your product benzoin is available or produced. This benzoin is also known as alpha hydroxy ketone. This benzoin or acetylene is also known as alpha hydroxy ketone. This is simple reaction and the mechanism is also simple, so that you can go through this. The next reaction is Novenger reaction. In Novenger reaction, when an active methylene compound reacts with an aldehyde or ketone in presence of a mild base, then it gives alpha beta unsaturated diester, and which on further hydrolysis gives to you alpha beta unsaturated carboxylic acid. In this particular reaction, ethyl acetoacetate reacts with an aldehyde in presence of a secondary amine base. Then it gives to you alpha beta unsaturated ester, and then on acid hydrolysis it gives to you carboxylic acid. Now let's see the mechanism of the reaction. This mechanism is slightly complicated because there is formation of an intermediate, that is enolate. In first step, in ethyl acetoacetate there are two active hydrogen atoms or two acidic protons present on the active methylene group. So one of these two protons can be abstracted by the mild base, that is secondary base, and there is formation of a carbanion. Now this carbanion undergoes delocalization and forms an enolate. This enolate exists as ketoenol tautomer, and so that there is formation of ketoenol tautomerism. And this compound is slightly stable due to delocalization of this enolate. Now this enolate attacks on the carbon of an aldehyde through carbanion, and there is formation of an oxyanion. All this is happening in situ, so that the base is also present in situ, and this oxyanion now abstracts a proton from the base, and there is formation of an intermediate. Now this intermediate undergo loss of water with a base, and it gives to you alpha beta unsaturated diester. This was all about the chemical reactions and the mechanisms of the benzene condensation and Novenger condensation. After this, we will continue the next reactions in next lecture. So thank you.